Hello everyone, welcome back to the new lecture. So in this lecture we'll discuss about the duct sizing methods. So here in duct sizing method, all of you know that there are three methods of duct sizing. The most widely used method to size ducting is the equal friction method. The other methods are velocity reduction and static regain. Okay, so the first method of duct sizing is equal friction method, second velocity reduction, and the third one is static regain method. So in this lecture, first we'll discuss about the first method of duct sizing, means equal friction method. Okay, so one by one we'll discuss each and every method. So what is the equal friction method? Okay, so remember the equal friction method or design method size the duct for a constant friction rate, which describe the average pressure drop per 100 feet of duct in a system. A very common friction rate for a reasonably well designed system is 0.1 inch of water column per 100 feet of duct length. So here you have to remember one point. The friction loss value is usually selected based on acceptable noise level and energy consumption, typically between 0.08 to 0.1 inches of water gauge per 100 feet of duct length. So at every 100 feet of duct length, if you are using equal friction method, so at every 100 feet of duct length we have to keep the friction constant, means 0.08 to 0.1 inch of water gauge per 100 feet of duct length, correct? And see, the next thing here, this method is commonly used for residential and commercial application. Okay, if you are running the duct work in residential and commercial building, so you can use this method. It is simple and widely used, especially for low pressure duct system. Okay, and it is also used where duct sizing length is a medium size, not larger size. Is it clear? Now here you can see as per SMACNA, Sheet Metal Air Conditioner Contractor National Association. So SMACNA typical recommends a friction loss, means how much friction we have to maintain. As I told you, in equal friction method, at every 100 feet of duct length we have to keep friction constant, na? So how much? So as per SMACNA, they have given the value 0.1 inch of water gauge per 100 feet of duct length. Okay, near about 0.82 Pascal per meter. So this value is widely used in the industry and provide a balance between energy efficiency and duct size, correct? Now here, as per ASHRAE guidelines also suggest maintain a friction loss of 0.1 inch of water column or water gauge per 100 feet of duct length as a common starting point. However, ASHRAE allows for some flexibility depending on the specific application and design requirement. So for example, in cases where noise control is critical, so a lower friction loss, example 0.08 inch of water column per 100 feet of duct length, might be used to reduce airflow velocity and noise. Okay, so that is why I am telling the friction loss is usually selected based on acceptable noise level and energy consumption, typically between 0.08 to 0.1 inch of water gauge per 100 feet of duct length, correct? So where in application where noise control is critical, so you have to maintain the friction loss 0.0 inch of water column. Okay, now when you see as per carrier design, you can see here, so this carrier design guideline are generally aligned with SMACNA and ASHRAE. Okay, so carrier often recommends a friction loss of 0.1 inch of water column or water gauge per 100 feet of duct for standard application. So while 0.1 inch of water per 100 feet is a common guideline, okay, designer may adjust this value based on factor such as noise requirement, energy efficiency goals, space constraint, and the type of system being designed. Example, high rise building may have different requirement compared to single story structure. Okay, so noise control, where the noise control is critical, so you have to go for 0.08 inch of water gauge. Okay, so lower friction loss, all of you know lower friction loss values can be selected to reduce airflow velocity and associated noise level in sensitive area such as offices, hospitals, and residential building. Better is to maintain how much friction loss? 0.08 inch of water gauge. Okay, and in that application where noise is not a factor, okay, so you can maintain up to 0.1, no problem. Okay, so these are the equal friction method, and how much friction loss we have to maintain, that also I have discussed. Now here we'll see the equal friction method of duct sizing. So here I am taking one example. See, in this example, try to understand, all of you. Here we have taken one ceiling suspended AHU. Okay, let's say the application for cafeteria generally we are using, and now via ductwork we are supplying conditioned air in this cafeteria. So suppose first of all we have to do the cooling load calculation, all of you know, by using the software, HAP software, E20 method, O general method, thumb rule. So you can calculate the cooling load value. Once you will get the cooling load value, now based on that cooling load and supply air CFM, you have to do the diffuser selection. Let's say we have selected here 6 number of diffuser, and the total supply air CFM which we have got from the cooling load calculation is 1200 CFM. How much air we need to supply from the ceiling suspended AHU? We are supplying 1200 CFM, cubic feet per minute air. So if you have selected 6 number of diffuser and the total supply air CFM is 1200, so each diffuser is of how much CFM? 1200 divided by 6. Okay, so each diffuser CFM, normally when you do 1200 divided by 6, you will get 200 CFM. Means from each diffuser we need to supply how much air? 200 CFM. So that we'll discuss. So first of all, let's start how to do the duct sizing by using equal friction method. So can you see here 1200? So first you have to open the McQuay duct sizer software here. See, you can see here I have opened the McQuay duct sizer software. So in that software, if you are using equal friction method, so 2 parameters you have to enter: flow rate and head loss, means friction loss value. Okay, automatically the system will give you the velocity, equivalent diameter. Okay, so here the flow rate is 1200, and the head loss which we have to maintain, as I already discussed with you, if you are designing the duct for sensitive area or where the noise is a factor, okay, so on that time how much friction loss we have to maintain? Sensitive areas such as offices like hospitals, residential building. Okay, so for example here I am maintaining 0.08 because the range I have already shown you as per different standard, 0.08 to 0.1 inch of water column per 100 feet of duct length. That much of friction loss we have to maintain. So here I am maintaining at every 100 feet of duct length we have to cap the friction 0.08. Suppose let's say 0. You can also select 0.1, no problem, but here I am designing for 0.0 because I want the noise level little bit down. But see, this application we are using for cafeteria. Okay, in cafeteria you can go for 0.1 also, no problem. Here noise is not a factor, but let's say I am designing point for 0.08. Okay, so as per this friction or head loss 0.08, see, when I have entered these two value, flow rate and head loss, now the velocity, equivalent diameter already we have got, and here we are selected the rectangular duct. Okay, remember one more thing. So now see the duct size. Here you have to, in the first box, just enter the height. how much height is available. As per that, you will get the width. So I am changing the unit because I want the size in millimeter. So from here you can change the unit as a metric. Okay, now we'll start from first. I am entering 100 height. So when I have entered 100 mm height, see we have got the width 2000. Remember, in case of rectangle duct, always we have to maintain the aspect ratio. I think all of you know about aspect ratio. Aspect ratio means what? Aspect ratio is the ratio of longer side of duct to the shorter size. Okay, that is called as aspect ratio. Is it clear? Now, it should always be, already I have discussed in detail, for rectangular duct as per SMACNA, the aspect ratio is between 1:4 or 4:1, you can say. So the value of the ratio of when you do the ratio, when you calculate the ratio of longer size of duct to the shorter size of duct, for example, in this case width is longer than height, na? So you can say like this also, width of duct divided by height of duct. So when you calculate the ratio of width by height, it should be between 1:4. It should be greater than equal to 1 and less than equal to 4. So this ratio you have to maintain. Okay, and better is what? Always try to maintain the ratio close to 1:1. Okay, because we know that the aspect ratio of a rectangular duct should ideally stay between 1:1 and 1:4, and designer aim to keep it as close to 1:1 as possible. Why? The reason is what? To optimize the airflow efficiency, because you know that a duct with a higher aspect ratio increase friction loss because the air has to travel along longer surfaces. Keeping the ratio close to 1:1 ensure smoother airflow, reduce turbulence and pressure losses. Okay, so that is why always try to maintain the aspect ratio close to 1:1. Okay, so when I am selecting the height 100, so we have got the width 2000. Now when you calculate the aspect ratio, width divided by height, 2000 divided by 100, you will get 20. So the condition is not satisfying because the aspect ratio is between 1:2, 1:4. Okay, it should always be greater than equal to 1 and less than equal to 4. So here the condition is not satisfying. Again I am increasing the height now 200. So when I have selected the height 200, the width we have got 725. So when you calculate the aspect ratio, 725 divided by 200, so you will get near about 3.6. Okay, condition is satisfied. The value is coming less than 4. No problem. As I told you, always the aspect ratio we have to maintain between 1:4. Okay, here the condition is satisfying, but problem is what? As I told you, always the aspect ratio of a rectangular duct should ideally stay between 1:4. And here our main target is what? Always keep the ratio close to 1:1. Ensure smoother airflow, reducing turbulence and pressure loss. So when I am selecting 200, so here okay, condition is satisfying, but the aspect ratio is coming closer to 4. 1:4, na? You can say, and it should always be closer to 1. So that is why here I am using the height 300. So when I have selected the height 300, now when you see the width is 450. Now when you calculate the aspect ratio 450 by 300, so you will get the value 1.5. So this value is closer to 1. Clear? So better is to take the height of duct is this 300 mm. Okay, so you have to select the height as per the space availability on site. Okay, so here right now 300 height and width of duct we have got 450 for 1200 CFM supply air, correct? So here I have written 450 by, always write down the larger size first and then shorter size. 450 by 300. 450 is the width of duct and 300 mm is the height. And when you are doing the sizing, remember, for the main duct always try to maintain the height constant. Okay, suppose in starting if you have taken the duct height 300, so always try to maintain the height for the main duct 300 only. Okay, so let's say for 1200 CFM we have got the size from McQuay 450 by 300. Now we are supplying 200 CFM in this diffuser, 200 here. So the remaining CFM is how much? When you see 800 CFM. So for 800 CFM, how much duct size? Again open it and change the unit first as IPS and write down here 800 CFM. Head loss we have to keep constant. Okay, so I have taken 0.08 only, and now I'm changing the unit as a metric. So now again, as I told you, for the straight duct always or the main duct, always try to maintain the height constant 300 only. As per this 300, see na size we have got 325. But here remember, don't need to select 325. We have to select the width 350. Why? The reason is what? Remember, the duct size are manufactured in standard dimension to simplify production and reduce cost. So using standard size minimize material wastage and ensure compatibility with commonly available fitting. For example, if 350 mm is a standard size, so it is easier and more economical to use that instead of custom fabricating 325 mm. So better is to, if this value is coming, just go for 350. Okay, some standard size of dimension the duct is fabricated are manufactured in some standard dimension as I told you. Okay, so 300 height and the width is 350, correct? So here for 800 CFM the size we have got 350 by 300. Now when you are supplying 200 CFM in this diffuser to here, so now the remaining is 400. So for 400 CFM how much size? Okay, again here I have opened the McQuay. First we'll change the unit as a IPS, write down 400, and now change the unit as a metric and see. Right now when you see the duct size, here I have taken the height 300. Now the width we are getting 200. When you calculate the aspect ratio width by height, so you will get the value less than 1. So it means here the condition is not satisfying. Aspect ratio should always be greater and equal to 1 and less than equal to 4. So here the condition is not satisfying. The value is coming, aspect ratio value is less than 1. So it means now you have to reduce the height of the main duct to increase the width. So now I am taking 250. So for 250, see, if I have taken this height 250, same width also we are getting 250 only. Okay, is it clear? So you can select 250 by 250 mm duct size from here. Now for the branch duct, see here the branch duct is going on, and each diffuser is of 200 CFM. So typical value you will get. So remember, for branch duct, if you are doing the sizing for branch duct, so the branch duct height should always be less than the height which you have taken for the main duct. Suppose here the main duct height we have taken 300 mm. So branch duct height should be less than the height of main duct. Okay, reason is what? You know that to fix the branch duct in the main duct we have a different flanges. For that we need space, minimum 50 mm. Okay, so that is why here I am just open the McQuay and see each diffuser CFM is 200. So first change the unit and write down 200. Now here height I am considering 200. 250 also you can select, no problem, because main duct height is 300 and branch duct height you can select 250. But problem is what? Now when you see here for 400 CFM we have reduces the height 250. So it means 250. Okay, for this branch duct possible 250. Okay, but when you are connecting this two branch duct, so again, so better is what? Now just take the height 200. Okay, as per that you will get the value 200 by 200. Okay, for branch duct. Is it clear? 200 by 200. Or you can also select the 150 also. See now, right now for in our see we have selected 150 height. So you can go for 150 also, it is depend on you, otherwise 200 by 200 also you can select. So see, I'm going for 150, so for 150 you will get near about 200. Okay, so it is depend on you, but this thing you have to remember, the height should be, for branch duct the height should be less than whatever height you have taken for the main duct. Okay, so in this way we have to do the duct sizing as per equal friction method. Hope all of you enjoy the session. See you in the next one.